Hello everyone, welcome to a new video and a new set of solutions for the CPP for school thing that we're going through. We're on assignments, flow of control, Sat 1, problem 4, and this is obviously on cppforschool.com. And in this series we're basically going through the entirety of these assignments and going to walk through all the solutions. So we got a little ways to go, so let's keep going. Now, last video we left off right after solving problem 3, so we're going to start on problem 4 here, and we're already in our folder. So we're going to go ahead and open up our coding program, which is Visual Studio Code here, and our makefile looks fine, and it looks like we just solved problem 3. Not going to worry about that extension right now. So problem 3 is looking good. We're going to go ahead and comment that out and move on to problem 4. So what this is asking for is, let's see, write a program to determine whether the seller has made profit or incurred loss. Also determine how much profit he made or how much loss he incurred. Cost, price, and selling price of an item is input by a user. Alright, well that's a pretty straightforward, just use a little subtraction and figure it out. So not a very hard one. We're going to need cost. Let's see, a float of cost, profit loss, cost, sell, profit, loss. So we're going to need all those. And we'll go ahead and ask for some stuff. Cost of item, so we'll get that. We'll also say item sold for, and we'll put sell there. And then after we have that information, we can do some processing. We can say if, let's see, cost minus sell is less than 0, then we can say loss equals cost minus sell. This might not be the best way of doing it, but it'll work. So if we buy it at a price, and then we sell it for another price, that's, well, there's probably a better way of saying this. Okay, so let's say we buy it for $2 and we sell it for $3. That's less than 0, so that's actually a profit if we're calculating like this. And how much profit? Well, it would be the cost minus the sell, but also it would be the absolute value of this. So whatever the difference is here. Now this is sort of a backwards way of doing the math, but that's the way it's coming to mind for me. So else, if this ends up being positive, then we lost because we sold it for less than we bought it for. So we would say loss equals, I guess this would just be plain old cost minus sell. And that way it's only going to work with one of these variables. So we could say, well, we could just do it all in the same one. Profit made, and that's going to be this profit. Put a new line there. And on this one, maybe we could say loss incurred or something like that. And let's go ahead and just give it a quick try. Okay, so we compile it, and we get a cost of an item. Let's say we bought something for, I don't know, let's say $50, and we ended up selling it for 55. Profit made 5 buckaroos. Alright, so that seems to be fine. Let's try it with a loss. Say we bought something for 45, and we can only manage to sell it for 35, and we incurred a loss of $10. So yeah, that seems to be straightforward enough to do the job. Now, like I was sort of mentioning, it's worth noting that there's a lot of different ways you could do this particular thing. So that's just one way of quickly getting it done. And I'm guessing the solution on here is going to look a little different, but as long as it gets you the results you need, an accurate number, then typically your function or program is fine. Let some hot coffee. Hot coffee. Okay, so number 5. Let's go to straight number 5. The ages of Ram and I'm not sure how to say that name, and AJ are input by the user. Write a program to determine the youngest of the three. The youngest of the three. Okay, well this is I'm sure a lot of you already know how to do this. Okay, let's just start. Well, the age is going to be an unsigned integer, because ages can't be negative, can they? You can't be like -1 year old. So unsigned means it's positive only. And integer, because we're not going to work with 0.5s, we're just going to go straight with years. We're not going to say like 5 years, 2 months, because it doesn't say to, it's not really specific. So we'll do RAM age, we'll do, so however you say this, age, and AJ age. And then we'll just take those in. Enter the ages of Ram, yeah, all these guys. Between. Okay, so with spaces in between, that'll basically just separate them out in this. So if you want them all at once, you can do something like this, and every space you put in the CN will separate it. So once we have the ages, we can take a quick look and just see which one is the lowest. Now, what's the most efficient way to flow this? I don't know. There's only three different cases, really. Either he's the old. Wait, let's see. This one the oldest, youngest. So one of them is the youngest. That's the basic 3 different cases. If RAM age is less than, so however you say that, age. Okay, then we'll say, I guess we'll do another if here. So RAM's age is less than this guy's, then, well, we'll just do it in line here. And RAM age is also less than AJ age. Well, RAM's the youngest. So there's, if RAM's the youngest, that will take care of it. So we could also do a few more cases here. Say else if. Now please, someone correct me in the comments of a better way to do this, because I'm not looking at the solution, I'm just doing this however it works. And it's probably a little long-winded and unnecessary, but that's okay, because sometimes you just got to get the job done. So now we're just checking if Salab, is that how you say that? Salab is younger than RAM and younger than AJ. Because if he is, then we could say that Salab if this is really pronounced slab, imagine being named Slab. I'm sorry if anyone gets named Slab. That's a real weird name. So the other case is AJ is the youngest, but we don't take into account some equality here, because I don't know, if some of these ages are the same number, then it's just going to say AJ is the youngest because we don't have a final case here. So what we're going to have to do is just improvise a little bit and say AJ age is less than RAM age. So yeah, this is going to have to be an else if rather than else, because we do need to do a little checking if we're going to consider ages that are equal, and maybe some error cases of that. So there we go, there's if AJ is the youngest. Now the final case here, basically if none of these other ones end up being true, is there is a tie for the youngest. And we'll just stop there. We'll not worry about saying that, because they don't say anything about saying anything further. Alright, let's go ahead and take a quick check on that. So enter the ages of RAM, Slab, and AJ with space in between. Let's say RAM is 28, Slab is 15, and AJ is, I don't know, 20. And it says Slab is the youngest with 15, so that looks good. Let's run it again, and this time we'll put in 10, 10, and 12, and we get a tie for the youngest. So this looks like it's going to work pretty consistently. A little flow of control with a big if else to determine that. And if you think about it, yeah, this makes sense, because there are 4 cases here. There's really 3 outcomes of one of the 3 being the youngest, or the tie case is the 4th outcome that's not really mentioned by the question at all, but it's got to be there. They don't say anything about equal or calculating months. We're just doing years. Okay, so let's move on. That was 5. Looks like we got time for maybe one more. Okay, so we're on 6. Write a program to check whether a triangle is valid or not. When the 3 angles of the triangle are entered by the user, a triangle is valid if the sum of all 3 angles is equal to 180 degrees. Right, okay, well that's pretty straightforward. So we'll take 6 here. Now obviously we can't have any negative angles, so rather than enter the ages, we're going to say enter the 3 triangle angles with spaces in between. And of course this can't be an unsigned integer, this has really got to be a float. But also, can there be negative angles? Not really. I mean, to some extent you could sometimes calculate them, but they just basically subtract off of 360, like negative 90 is 270 degrees. Hope that makes sense. So we'll just say angle 1, angle 2, angle 3, etc. So we'll get the 3 angles in, and they are floats. And we want to make sure none of these are negative, I guess. Well, forget it. It doesn't matter. We're not even going to check that. I mean, in a real program, you probably would. So if those are equal to 180 degrees, we'll say that is a legal triangle. Otherwise, it's not. And there we go. That should be enough to take care of the basics of that question. So let's say we have, I don't know, a 50-degree angle, a 45-degree angle, and a 20-degree angle. And we get that as a legal triangle. So let's run it again. Let's see if we can get a legal triangle in here. Let's see, what if we get a 90 and what, two 45s, a 45 and a 45. That's legal. That is a legal triangle. Very good. So you could put in all kinds of numbers there and it will just spit it out. If they equal exactly 180, then we're good. Otherwise, it's not a legal triangle. Okay, that's all the time we have for today. Thanks for tuning in. I hope this helps some people out there figure out some flow of control and some basics of C++ and how to write some basic logic. And I'll see you in the next episode where we will pick up on flow of control question 7 and see how far we can get. Thank you very much. Peace out.